Hey, how's it going? Welcome to my video on neural style transfer. So just to give you a little background on what neural style transfer is, it's using neural networks to do an AI to do a technique called style transfer, which is basically taking the style from one image and applying it to another image. Now, I'm demonstrating this for educational purposes. This day and age of advanced AI, people are doing this constantly using DALL-E and other systems to generate an image in the style of X, Y, and Z artist. That's not the purpose of this. The purpose is to advocate actually for the understanding of how this occurs, and to kind of like advocate for the awareness for artists to, like, you know, have not have their style stolen, essentially. But what I'm going to be talking about is kind of like the overarching technique. So style transfer dates back to the 80s and 90s, when people used, for image processing, signal processing techniques to do a lot of image manipulation and things like that using filters. And as so people were able to take image styles, code up a very complex image processing filter, and then take that style and apply it to another image. And this technique advanced over time until about 2015, when neural networks, specifically the convolutional neural network, which came about a few years earlier as an amazing replacement for signal processing and image processing techniques, came by and essentially changed the landscape completely. So style transfer, a paper in 2015 was released called A Neural Algorithm of Artistic Style, and it used the convolutional neural network to show that you can actually, without much filter design like you had to do way back in the day in the signal processing days, you could actually take the style of an image and you could apply it using the layers of the convolutional neural network, which extract features automatically. And you can extract style features from the network and content features, and these are separated in a way that corresponds to the layers of the network. So the shallower layers correspond to the style layers. The deeper layers, of course, which have more geometry and more complex detail, correspond to the content layers. So by combining the results of both of those, you could actually produce a combined stylized image, if you take from two different sources. So, and again, the style transfer mechanism has been increasing in efficiency and capability over the last few years, where it was originally very slow, and then a technique known as fast neural style transfer came in and kind of blew the whole thing out of the water. So yeah, so what I'll be showing you is that I am going to take an image, a style image here. Okay, this is like a waterfall that's colorized, and I'm going to take a content image here, and this is a person with a camera, and I'm going to attempt to apply the style image to the content image, the style of the waterfall with the colors and rainbows to the content image. Okay, so what we're going to do is we're going to actually write an algorithm here that uses a library that already kind of does this, but we could actually write this from scratch, but it would be much more complicated and involve a lot more specific neural network design. And I can actually do that as a follow-up, as an educational series, but for now, just to demonstrate using an optimized method how this works, we'll just use this model. So first, we're going to do everything in TensorFlow. So I'm going to get my TensorFlow dependencies. TensorFlow is TFs, import, and now we're going to pull the model from TensorFlow Hub. Flow Hub as hub. Import NumPy as NP. NumPy to do obviously our array and matrix manipulation. We're going to do our plotting. Matplotlib. PyPlot as PLT, and then we're going to use fill to get our image. We get an image abstraction that we put in memory. And then we're going to mount our Google Drive, because I showed you that the source images are on Google Drive, and Colab has some nice utilities to do this automatically. So first we mount our drive. Okay. And it's going to ask you permission if you haven't done this already for your particular session to do this, to get access to your drive. So first thing we're going to do is load our image. Okay, the image is going to have a path as a parameter. We're going to specify the max dim of the image. So I'm going to load images of different dimensions, and the maximum dimension is going to be 512 by 512. And so we can do more, but there's reasons, and we want to keep it simple and straightforward and timely. So I'm going to read the file using TensorFlow also, because it's convenient. Image path. Then I'm going to decode the image, and then the whole point of what I'm going to do now is to take the input image and then try to make it conditioned to be inputted into the model. So I have to do a few transformations on that, including ensure the data type is float32. So I'm going to convert the D type of the image and output it again to itself, float32. Okay. And now we're going to reshape this image to make sure that the shape is uniform and square. And we're also going to do some other shape manipulations to make sure the model can take this image in. So we shape all the dimensions. Let's see, image. We don't want to IMG or image. I always I can never decide between both of those. Okay. So we shape our image, not float 332, and now we're going to scale our image, so we can do a little bit of balanced input output by long dim. Okay, cool. Mixed dim. Okay, and so yeah, let's see, long dim, not dime. Okay, and then again I'm gonna do another shape cast by scale, and now we're gonna finally resize the image. So we're gonna fit this new shape that we've generated. Shape. New shape. Okay, and shape that scale. This should be scale, not cast. Okay, cool. And we're going. This is all just like, you know, basic manipulation stuff to make sure the thing works. Probably the least interesting, but it's required. And then we're going to return the image. Okay, so now we have our image loading function set up. Then what we're going to do, I'm going to specify a path to our content image. So I'm going to call this content. I'm going to use the canonical drive path here. By default, when you mount your drive, or when you create your drive, it's going to have this. We're going to call it content image. Image.png. And then we're going to copy this. I don't need another path thing here. And I'm going to call this style image. Hope this works. Pretty sure this will work. Oh, and I put it in the NST folder, so that's my go-to NST style. Okay, cool. So now we have our style image and content image. We have to actually load them into memory. So I'm going to do that. Equals load image, content image path. And I don't use autocomplete or any sort of, for this kind of stuff, or what is it? The generative completion, because I think the whole point is to learn this stuff and to teach this stuff. So okay, cool. So this is our style and content images, and we've done a lot already. So now we're going to actually print out the output image, right, for completion's sake. So I'm going to put that on a figure, and we're going to say it's 12 by 6, so we encompass all the real estate we need. And I'm gonna put the original images on top, so I'm organizing my subplot in such a way to be able to do that. Image 0, okay. All right, that's our content image. Then content image, you call it whatever we want. It's going to keep the axes off because this is not a actual bar chart or some line graph. It's just where we're putting our images. 1, 2, 2. Okay, so our subplot. Now we're going to output our style image, and we're almost done with this. Yes, it's actually going to not be too involved. So we have our style image, and we're showing our content image. Okay, cool. And then we're going to load. So from TensorFlow Lite, not TensorFlow Lite, TensorFlow Hub, there's an image, a fast style transfer library that's pre-compiled, but it's been around for a bit, I believe. And then we're using a magenta model here, style eyes, I believe. Yeah, so it's called arbitrary image stylization, not stylization. Stylization. It's a mouthful. V1 256 2. Okay. I probably stylization. Arbitrary image. And it's TF-Hub dev. I'm just making sure I got my URL right. Google. No, it's Google. Maintains TF-Hub. Okay, so this should be right. And now we have our model loaded. It's going to be basically we're going to load our content image into the model and our style image. So they've set up this model real nice parameterized, so we can just pass image data in there. And so we're passing our style image and our content image, and our final stylized image is going to be the 0th index output there. Okay, and now we're almost done. All we need to do is now plot the image, because this is all that it takes. And now, again, I say that this is the fast way of doing this, but the actual more complicated way involves the design of your convolutional neural nets, which I will do a follow-up video on, which would be a long video, and the basic setup of that is slow. These fast methods take a long time to actually build, and they're non-trivial. But just for educational, super educational purposes, I plan to show the fast version. Stylized image. Okay, and now this should do it. Okay, now you see our content image is this person, our style image is this here, and as you can see, the output is the stylized image of this person, taken from the rainbow waterfall style and applied to this person's background and this person's clothing and everything else, right? So fascinating. Now I have a secondary style image, this thing here. Let's see what this does. Okay, I'll call it style image 2, and I'm gonna load this. See if this, okay, there's my style image, this sketchy image here, and yeah, kind of like applied the sketch style a little bit to this. Not exactly, but more so, you know. Okay, and so you can see that I can take, and I can also change the parameters here and whatnot, and get a more abstract and more accurate representation of the style and apply it to the image. Okay, great. So thanks for watching my video. Appreciate it, and I will see y'all next time. And like and subscribe.